Good morning, Year 7s, and welcome to another lesson. A few tips for those working at home. Try to work in a quiet area with little distractions. Read all slides and questions carefully. Remember that help is here if you get stuck. A teacher will be available to answer questions in normal school hours. Homework will need to be completed and posted by the deadline. For today's lesson, driving question. This isn't a question, because we will be doing an overview of everything that we have done in this term. There are a few objectives that I am expecting for us to cover by the end of this lesson. Everyone must be able to describe what a mixture is. Most should be able to describe, explain, and give examples of specific processes of separation. Some will be able to give suitable separation techniques for mixtures when given information. Keywords that we'll be using is chromatography, mix or mixtures, separation, filtration, crystallization, distillation, solution, and substance. Again, the keywords: chromatography, mixtures or mix, separation, filtration, crystallization, distillation, solution, and substance. Now, for your remember task, this is a true or false activity. Please pause the video, give yourselves 5 minutes to complete the task. Being that you're working from home, you could just read each of the given statements, write true or false. At the end of the 5 minutes, please start your video as I will be going through the answers. Please pause your videos. Welcome back. Statement 1. Everything is made up of atoms. True or false? Answer is true. Were you correct? Write yes. If not, you need to write that everything is made up of atoms. Second statement. Protons and electrons are found in the nucleus. Is this true or false? This is false. What is found in the center of the nucleus? They are protons and neutrons. Electrons are found on the shells. Was I correct? If you were, write yes. If not, write the correct answer. Statement 3. The mass of an electron is equal to the mass of the neutron. Answer is false. They're not. If you were correct, please tick yes or write yes. If not, write no, then write the correct answer. Statement number 4. The number of protons in an atom is equal to the atomic number. True. Always remember that the atomic number is always equal to the number of protons and also equal to the number of electrons. If you did get this right, you write yes. If not, tick no and write the correct answer. Other statements. Electrons on the outermost energy level of an atom are called valence electrons. Now the answer was already there. Answer is true. If not, and you got it incorrectly, please write the correct answer. Neutrons and electrons are attracted to one another. True or false? The answer is false. Remember, electrons are negatively charged. Neutrons have no charge. Protons are positively charged. So if neutrons have no charge and electrons are negatively charged and the protons are positively charged, it simply means that the electrons are attracted by the protons. Opposites attract. If you got this correct, write yes. If not, write the correct answer. Different atoms of the same element can have different number of neutrons. Answer is no. So it is false. At your level, we'll write this as being false. When you get to your 9, 10, and level 11, we'll be looking at isotopes. Isotopes are different forms of the same elements with the same numbers of protons and electrons, but their number of neutrons are different. But for now, we settle with false. And the last one, on the first energy level, you can only have 4 electrons. True or false? The answer is false. The first electron shell can only hold a maximum of 2 electrons. Again, the first energy level can hold a maximum of 2 electrons. So were you correct? Yes? No? If you weren't correct, please write the correct answer. Now, please bear in mind that this is a review of what we have done in this term. Now, first question. What are mixtures? A mixture contains different substances that are not chemically joined to each other. For example, a packet of sweets may contain a mixture of different colored sweets. Can you think of a pack of sweets that have different colors? Skittles, Taste the Rainbow, is an example. Let's say that this is the Skittles from the bag. We will have green, yellow, red, and orange Skittles. Now, this would represent a mixture. Why? We're able to separate the different colors into groups because they are not joined together by no way, form, or shape. How would you separate this mixture? Now, there are 4 specific ways of separating mixtures in science that we'll be looking at very briefly at the end of today's lesson. Now, how would you separate this mixture? Do you think that this would need a specific scientific method of separating, or would you just be able to pick the colors out? If you probably had decided on the last one, you were correct. The sweets are not joined to each other, so they can be picked out and put into separate piles. Now, a few key points about mixtures that you must remember. A mixture consists of 2 or more elements or compounds not chemically bind to each other or combined rather. The chemical properties of each substance in a mixture are unchanged. Again, a mixture consists of 2 or more elements or compounds chemically combined together. They are not chemically combined. The chemical properties of each substance in a mixture are unchanged. Now, if we have 2 elements that are mixed together, but they are not chemically bonded, it will not become a compound but remain a mixture. You can remove or separate these elements into their different components while allowing them to keep their properties. However, looking at a compound, once we mix 2 elements and they have become a compound, they will lose their individual properties. Remember when we looked at sodium chloride, table salt, chlorine, and sodium are not very wise for us to consume individually because of their individual and unique properties. However, when we put these substances together, It is very good for health, but remember, take everything in moderation. Extra information that you must remember. There are two types of mixtures. Can you remember what are the two types of mixtures? Hmm. They are homogeneous mixtures and heterogeneous mixtures. Do you remember the differences between the two? Hmm. Let's see. Homogeneous mixtures. A homogeneous mixture is a mixture that is really well mixed. It is so well mixed that you cannot see the different parts of a mixture. Can you think of any such mixture? Homogeneous. Like mixing two of your favorite drinks together. Once you mix them, you might see a color change. Like, can you pick out the particles of one flavor of your drinks? No, you cannot. However, heterogeneous mixtures. Heterogeneous mixtures are mixtures that are not well mixed. You could see the individual pieces that are mixed together. Can you think of any mixture? The most common heterogeneous mixtures that we know to date is oil and water. It doesn't matter how you pour the oil into the water, you stir the mixture. The oil will always go to the top and the water goes to the bottom because they have different densities. But that's for a different lesson. Now, there are two simple properties that I want you to remember as it pertains to mixtures. That the components or different parts of a mixture can be easily separated. Two, the components keep their original properties. Again, the components or parts of a mixture can be easily separated. We do not require a scientific method to separate the mixtures. Secondly, the components each keep their original properties. Remember, sodium chloride is a compound. They will lose their unique individual properties because they have bonded with each other. But in a mixture, they are not bonded to each other, so they keep their original properties. What do they look like? Mixtures, heterogeneous mixture. Remember, oil and water. The oil will always settle at the top and water to the bottom because one is heavier than the other. Homogeneous mixtures are well mixed together. The particles are evenly distributed, and you cannot distinctly pick one atom of that element in the mixture apart from the other. It's well hidden. Now, a comparison between mixture and compounds. This is a yellow slide, and I would appreciate it if you would pause the video, take a minute or two, read these for yourselves. Comparison between mixtures and compounds. In mixtures, variable composition. Vary the amount of each substance in a mixture. So the components in a mixture might vary in composition. For compound, definite composition. Can't vary the amount of each component in a compound. 2. Mixtures. Different substances are not chemically joined together. Compound. Different elements are chemically joined together. 3. Each substance in the mixture keeps its own properties. 4. The compound has properties which are different from the element it contains. 5. Each substance is easily separated from the mixture. For compounds, it can only be separated into elements using chemical reactions. But always remember, not all chemical reactions can be reversed. Alright, so an example of a mixture, air and seawater. A compound, Example, water, carbon dioxide, sodium chloride, and calcium oxide. Now, looking at some very famous S words that we use a lot: solvent, solute, solution, and soluble. Do you guys remember us using these words? Let's have a go. When a solid dissolves in a liquid, it forms a special type of mixture called a solution. Now, there are different parts to a solution. We have what we call the solvent. The solvent is the liquid or substance that does the dissolving. Now, we have different forms of solvents in science, but the most common one that we use is water. The solutes, the substance being dissolved. In brackets, a solution can have more than one solute, but only one solvent. So you can add, for example, do not try this at home, add water, sugar, and salt together. You can mix them together and they will dissolve. Now, we have two solutes in this case. The two solutes would be salt and sugar, but the solvent is the water. Now, what would that solution be? Salt, sugar, water, water with sugar and salt, sugar, salt, water. Well, who knows? It varies. It's up to you. But the solute is that one bit or that substance that is being dissolved in a solution. Once we add the solvent, or solute rather, to our solvent, we end up with a solution. Solution is formed when solvent and solute mix together. Now, how would you separate this mixture? Now, this is where one of the scientific methods would come in very handy. And this one would be, can you have a guess? This one would be crystallization. What does the word crystallization means? Or what does it suggest? Crystallization. Crystallization is basically turning something into a crystal. Did you get that? All right. Now, this is a very tedious task, but once you understand the concept, it is very easy for you to get. Now, we have a solute and a solvent. Remember I said in most cases, the solvent in science would be water, but this isn't always the case. All right. Now, this is a reaction when we would be making some crystals. The most common crystals that we make in science is copper sulfate. And copper sulfate is made by mixing copper oxide, which is a powder, which is the solute, which will be dissolved into a liquid, which is sulfuric acid. So an acid, in this case, sulfuric acid, would be the solvent and not a water. Remember, we have different solvents that we use in science. Water is just the most common one used. Right? So the solute, which is the bit that will be dissolved, is the copper oxide, and the solvent that does the dissolving would be the what? What would it be? So the copper, the sulfuric acid rather, would be the bit that will be doing the dissolving. And once we mix the copper oxide rather, and sulfuric acid, we end up with a solution. Now, how can we get the copper oxide out of the solution? Now, in this case, remember we said that not all chemical reactions can be reversed. However, in this one, we'll add the solute to the solution, then we'll end up with some excess in the bottom eventually. What we'll do, we'll pour the mixture through a filter funnel and filter paper to get the liquid. The liquid is what we want. Once we get the liquid right here, we put it into what we call a evaporating dish. Now, once we get and collect all the liquids, we put it onto our Bunsen burner. What this does is to boil the substance just to evaporate the water. Now, once this is hot enough, we transfer the hot liquid to a dish and allow the water, not water, but acid excess to evaporate, only leaving the crystals. Now, what will the crystals look like? This is what the blue crystals would look like. Now, remember, not all chemical reactions can be reversed. So remember we started with a powder, now we ended up with a crystal. But this is what crystallization is. This is how we would separate the solution to get a solid. A solid does not disappear when it dissolves to form a solution. What happens to the particles? Now we have a solute plus a solvent equals a solution. Remember, we have salt and we have water. We mix them together, we get a solution of salt water. Now in a solution, the particles from the solute are not longer closely packed together. They are evenly spread out between the particles of these solvents. So not because we're not able to see the salt in the water, it means that it's not there. If we are able to weigh the water and the salt individually, then add the two masses. At the end, if we should weigh the mass of the solution, we will end up with the combined mass before. Remember, we looked at conservation of mass, where mass cannot be created or destroyed, but converted from one form to another. Remember that. Law of conservation of mass. If you did not get that, please pause the video and go and research the conservation of mass. What is it? Now, two terms that students normally get mixed up with. Why is dissolving not the same as melting? Can you think about this? Why is dissolving not the same as melting? Remember, if something is dissolving, it involves two materials. The resulting solution is a mixture of both, two things. All right? However, melting, only one substance is involved, and the liquid and the solid is the same material. So again, dissolving, this involves two materials. The resulting solution is a mixture of both. So this one, my apologies. So solute plus solvent gives a solution. Dissolving, the solute is dissolving in the solvent. At the end, this solution still contains the solvent and the solute. However, in melting, it contains the same substance when it was in the solid state and also in the molten state. For example, water. Water in its molten state and in its frozen states are two different states but contains the same chemical properties or the same elements. All right? Did you get that? Now, another word that we will be looking at is solubility. You did this in last week's lesson. A solution is a special type of mixture that is made when a solid dissolves and mixes in a liquid. For example, a cup of instant coffee is a solution. The solid that dissolves is the coffee granules and is called the solute. The liquid that does the dissolving, the hot water, is called the solvent. Always remember, The solute is what is being dissolved, and the solvent is what that does the dissolving. How many other examples can you give? We have a lot of examples. Seawater, gasoline, glass, steel, and air. Those are all different examples of mixtures. All right. Checking purity of substances. How can we tell if a substance is pure or impure? Remember when we look at the graph, remember a pure substance will melt or change phases with a sharp and precise point. For a substance that is impure, there is not one steady point where the change of phase is taking place. How can you tell? A pure substance has its own particular melting points and boiling points, the specific point at which it boils and melts. One way to check the purity of a liquid is to measure its boiling point. For example, pure water boils at 100 degrees Celsius. It contains, if it contains any dissolved solids, its boiling point will be higher than this. All right. So again, every substance that is pure has its own particular melting and boiling points. One way to check the purity of the separated liquid is to measure its boiling points. For example, pure water boils at 100 degrees Celsius. If it contains any dissolved solids, its boiling point will be higher than this. Now, let's look at this. Do you remember the slide? If you keep adding sugar to hot tea, does the sugar keep dissolving? Do you want to give this a try at home? Boil some hot water, pour it in a cup, add sugar. Tell me if it dissolved after a while. Does it keep dissolving or does it stop? Let's look. 1. Stir. Why not pour the entire bag? It will dissolve until it cannot be dissolved anymore. Now, there is a limit to the amount of sugar that can be dissolved. When no more sugar can be dissolved, the solution is called or considered to be saturated. It simply means that the particles of the sugar can no longer be dissolved into the solution, and once it gets to this stage, it starts to pile because it cannot be evenly distributed anymore in the liquid. So the liquid is said to become saturated. Now, there are four main types of separating techniques. Now, you will need to remember these four for the next activity that comes up. Now, the first one is filtration. Now, filtration, as you can see, there are different parts to filtration. We have the filter paper, filter funnel, the clamp, the residue or sand, conical flask, and the filtrate, which is the water. Now let's say that we had a mixture of sand and water, and we wanted to get the water alone. This is how we would separate the mixture. By pouring the mixture, sand and water, into a filter funnel with filter paper, and the sand will be separated from the solutes. Now, the sand that is left in your funnel is called the residue. What we'll collect into our conical flask would be the filtrate, which is the water. So once they are separated, they have specific names. So again, what is left in the filter funnel is called the residue, which is the sand. What is being collected into the conical flask is called the filtrate, which is the water. The second one is distillation. This is when we mix two liquids, but in order to separate them, these liquids must have separate boiling points. Now, what will happen? One will evaporate, leaving the other behind. Now, the one that has the lowest boiling point will evaporate first. What happens once it turns into vapor? It goes up, goes into the tube. What's going in and out of the tube is cold water. So as the hot steam goes up, goes into the delivery tube, cold water goes in and flows out to cool the vapor, causing it to condense, turn into a liquid. Then we can collect our liquid here. So again, distillation is used to separate two liquids of different boiling points. The one that has the lowest boiling point will evaporate first, leaving the other one. Once it changes from a liquid to a gas, it rises, goes into the delivery tube. The cold water that enters and leaves this tube cools the vapor, turns it back into water, and then you can get your other solution right here. Crystallization. We looked at this one before. This involves separating a dissolved substance. So we have the solution, one solid and insoluble impurity. We mix them. What we'll do here, we'll filter the mixture, only leaving the liquid. We'll heat the liquid. Once this is heated enough, we pour it into a dish, only to leave the dish to allow the liquid to evaporate, only leaving the crystals. You remember the pretty blue crystals that we saw before? That's it. And the last one is chromatography. Now, we did this one before, year sevens. What did we do with this one? This is to separate different colors in an ink. So we can identify an ink based on its composition. Now, in this scenario, you'll be given 3 pens, and you'll be asked to identify one particular pen based on the different inks that makes it up. Remember, inks are made from different colors. So once we're able to separate the colors, we can identify which pen matches the one that we're looking for. So 1, this is used to separate a solution where the solute did not dissolve in the solvent. Distillation is used to separate two liquids of separate boiling points. Chromatography is used to identify different colors that makes up a substance. And crystallization is removing crystals from a solution. The last point. Match the separating techniques to their definition. Remember, I was asking you to pay attention in the previous slides. Now, can you pause this video, give yourselves 5 minutes to complete this task? Welcome back. Chromatography. What is the definition of chromatography? Chromatography is a technique that is used to separate liquids of different colors. You remember the pen. Distillation. Why did we use distillation? To separate liquids with different boiling points. Remember the tube. Filtration, the very first one. What is filtration? Separates a solid that cannot be dissolved. Alright, so sand and water. We use the process of filtration to separate sand and water. And evaporation is separates a liquid and solid by boiling off the liquid. Now this takes us to the end of today's lesson. Please go to Google Classroom to complete the quiz. Until next time, be blessed.